Okay, this is about real numbers, and real numbers are made up of two types, rational and irrational. But rational numbers are numbers that can be written in the form of A divided by B. Rational, think of the word fraction, F-R-A-T-I-O-N. You just have an F in it and drop the A. There's the word fraction and add a C. Fraction, rational, fraction. Rational numbers can be written as fraction. It says where A and B's are integers, provided B doesn't equal 0. That's like a legal disclaimer lawyer. Basically, it means this. Rational numbers are any number that can be written as a fraction, including integers, like that's numbers like -5 and 4, because 4 technically can be written as 4 over 1, or -5 can be written as -5 over 1. Fractions, obviously, would be rational because they're a fraction. And what we call terminating and repeating decimals. Those are decimals that we can make into fractions. Any decimal we can make into a fraction is a rational one. If we can't make it into a fraction, it's considered irrational. And what we call perfect square root numbers, like the square root of 25, because the square root of 25 is 5. And like, just name some right there, like the square root of 25 is 5, so that would be a rational number. The square root of 3 is not, okay? And if they're not, they're considered to be irrationals. So irrationals are decimals are basically non-repeating and non-terminating decimals, the opposite of the rational ones, and square root numbers that are not perfect squares. So some examples of those would be, remember pi, like 3.14159, it keeps going, doesn't make something exact. Also the e, sometimes you see 2.71 something or other, or you'll see a number like 1.23578296, or it just keeps going and going with no repeating stuff, just making something up. Okay? And perfect squares are the products of a number times itself, so the square roots are always integers. In other words, like I talked about, the square root of 25 is 5, yet the square root of 25 could also be -5. Because what is -5 times -5? It is a positive 25. So, let's get a little practice in. Can you tell whether it's rational or not? Look at this first one. It's terminal, meaning it ends. So therefore, it is considered to be a rational one. It is rational. Now look at B. It goes 1, 2, 1, 2, 1, 2, 1, 2, repeats. If it's repeating, it's considered to be rational. Oh, I could tell you, like, that's how you could prove it is, by making it into a fraction. This one you can make into a fraction. I'm just going to show you this. Technically the definition is 12 over 99. But all you need to know is yes. Don't worry about this part here. It's kind of an algebra 2 thing. But yes, it is irrational. Now the square root of 8. If you put square root of 8 in a calculator, you're going to get like 2 point, I think maybe 7 or 8 or 9 even, I don't know. But it goes on and on and on, so it is not irrational. And this one right here, notice, do any of the numbers repeat? No, there's no pattern, so it is considered, that one does not repeat, and this one does not repeat. That's why these are considered irrational, these are considered rational. Decimals that end are terminal, or decimals that repeat. If they go on and on and on, like my voice, they are not rational numbers. All right.